Hello everyone. We are now on to the final unit of the course, animation. So there won't be a major assignment in this unit, but we'll be doing a number of class exercises and modules to build up some knowledge at least, and to have a little bit of experience. So I don't know if you remember, but towards the beginning of the course, probably week 2, we were going over vectors. I tried to sneak in an exercise on figuring out whether two circles intersected. So given two centers and the respective radii, tell whether they intersect. So these intersect, they intersect, they intersect, they don't. I'll make this radius bigger, they intersect, now they don't. Of course I can move the second one around. They intersect, now they don't. Now they just barely intersect, now they don't. And you can generalize this too. If you add a coordinate, you can make a center in 3D and now you have a sphere. So I want to answer the same question about spheres. Now why do I care about this? What does this have to do with animation? So one of the things that we have to do in animation is detect collisions. So we're going to be working, you'll see tomorrow, we're going to be working on dynamic scene graphs. So the objects are actually going to move around. They're going to change their position orientation. And we want to know when two objects are going to hit each other, because maybe we're going to respond to that. Maybe there'll be an explosion, or maybe one of them will bounce off or something else will happen. But we don't know whether, that's not something, we have to tell the computer when to know that two things are intersecting. I'll show you a slightly fancier way than this on Friday, but a very simple, basic thing you can do is put a bounding sphere around each object. So put a sphere that fits as tight as it can around each object. So that's one around the plane there, and then I'll put one around the boat. Now I won't, the sphere around the boat's probably not going to be so good because the boat's pretty wide. So I'll have a lot of wasted space at the top and the bottom. But this is supposed to give me, this is our starting point, and this can give you a rough estimate. So, you know, it's going to say that they don't intersect now. It will have some false positives because the spheres include volume that aren't actually in the object. So it'll think that the plane and the boat intersect here. But if the spheres don't intersect, it's absolutely true that the objects don't intersect. So you can use that to rule things out. So if the spheres don't intersect, you don't even need to do anything fancier. If the spheres do intersect, you may be happy with that. You know, in this animation, you would find that the plane kind of bounced off. It would look like it was bouncing off of thin air, and that's not quite right. But again, this is the starting point. Okay, so how do we do this? So let's just talk about this. One of the reasons we do this is because the math is so simple. So if I have a sphere with, I'll call it center C1, and radius R1, and then I have another sphere, so I have another sphere over here with center C2, radius R2, I can determine whether they intersect simply by constructing a vector between the centers and looking at its magnitude. So really I just want the length of this vector. I want to make this an arrow. Whoops. Okay. So here is the vector from C1 to C2. So that would be, I'll call it V. So V is equal to C2 minus C1. So these are vectors. And if they intersect, then here's what happens. Let's look carefully. So I'm going to make them intersect here. So I'll move this one over a little bit so that they're just intersecting. So if I look at that vector from the center of one to the other one, what I notice is the length of that vector is actually less than the sum of the two radii. So here is the first radius. That's R1. And then here is the second radius. Oops, let me really get this on there. The second radius is here, R2. So here's R2. And here's R1, that length. So what you see is that R1 plus R2 actually is greater than the length of this vector. See how there's a little bit of extra where they overlap here? So you get that comes out as a larger distance when you sum the two radii. So the condition is if R1 plus R2 is greater than the magnitude of C2 minus C1 or C1 minus C2, then they intersect. Actually, it's probably a little clearer if I write it the other way around. If the distance between the two centers is less than the sum of the radii, then they intersect, and it's really as simple as that. So this is a pretty quick check, and it's easy to do. If you wanted to save yourself a square root, you could just square both sides, and so you would get, this is just the dot, that would then be the dot product of C2 minus C1 with itself is less than R1 squared plus 2R1 R2 plus R2 squared, so you'd FOIL there. Okay, that's it. So I would like you to implement this in JavaScript real quick, and we will use it tomorrow.